Bismillahirrahmanirrahim. Start with the name of Allah, the most beneficent and the most merciful. This is Anas Ali Khan, a mechanical engineering student from Andy University of Engineering and Technology, along with my group mate Behrouz Farooq. The topic of our presentation is Artificial Intelligence for the Fault Diagnosis of Rotating Machinery, supervised by Sir Adil Arif, to whom we are grateful that he has provided us with the golden opportunity to gain modern knowledge and to enhance our skill. Now, in order to understand our topic, first of all, we have to understood that what is artificial intelligence. Artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term may also be applied to any machine that exhibits traits associated with the human mind, such as learning and problem solving. Now, my partner will continue the presentation and will explain you that what is the relation between the artificial intelligence and rotating machinery.
Assalamu alaikum. I am Behrouz Farooq. Abstract. Fault diagnosis of rotating machinery plays a significant role for the reliability and safety of modern industrial systems. As an emerging field in industrial applications and an effective solution for fault recognition, artificial intelligence techniques have been receiving increasing attention from academia and industry. However, great challenges are met by the intelligence methods under the different real operating conditions. This presentation attempts to present a comprehensive review of artificial intelligence algorithms in the rotating machinery fault diagnosis from both the views of theory background and industrial applications. Introduction. With the rapid development of technology and science, mechanical equipment in modern industry becomes more and more functional and complex. Rotating machinery is among the most important equipments in modern industrial applications. Fault diagnosis of rotating machinery becomes the most critical aspect in the system design and maintenance. Various endeavors have been made to improve the exactness and proficiency of fault analysis of rotating machinery by utilizing AI methods. Because of the variability and richness of response signals, it is almost impossible to detect error patterns directly. Therefore, a standard error diagnostic system usually has three important steps. This data flow diagram clearly explains the three different important aspects. Data collection. In this phase, data is collected from various machines under different working conditions. Feature extraction. Now, different features are extracted from the data collected in the first phase. Finally, the fault identification is done by use of various AI techniques, for example, neural networks, fuzzy sets, expert systems, and other hybrid AI techniques. Now, the old traditional methods of fault recognition have been discarded, and recently modern methods of AI and ML are being introduced. Commonly, AI techniques in fault diagnosis of rotating machinery can be categorized into three types: supervised learning, semi supervised learning, and unsupervised learning. Supervised learning. It is a machine learning technique that extracts its features from a set of labeled data in order to map desired input-output pairs. A direct feedback control system also ensures the precision of output. If the desired output is not obtained, the automatic feedback control determines the error in it and send it back to the learning agent so the error in the result can be minimized. Supervised learning includes all the regression and classification based algorithms, e.g., naive Bayes classifier, support vector machines, SVM, etc. Unsupervised learning, a technique of machine learning which uses unlabeled data for its feature extraction, means there is no fixed output variable, so that the model learns by itself by discovering the patterns and features in the data and returns the output. It has no feedback control system. Unsupervised learning is mainly based on clustering based algorithms. For example, k-nearest neighbor methods, selective, convolutional networks, neural network, semi-supervised learning. This learning method is an intermediate among supervised and and unsupervised learning. It uses both labeled and unlabeled data during training. It is used because it is not possible to obtain labeled data every time, but labeled data can produce considerable improvement in learning accuracy. Since the acquisition of unlabeled data is relatively inexpensive, adding a small portion of expensive labeled to it is overall cheap and gives extremely great result in comparison with only unlabeled data. Now, Anas will describe the different AI algorithms that are discussed in our research paper.
Now I will explain you different artificial intelligence algorithms in the fault diagnosis of rotating machinery. The first method that is used in the machine learning is the k-nearest neighbor method, which is a clustering based algorithm. The second one is the naive Bayes classifier, which works on the principle of conditional probability. The third one is the support vector machinery, which is also called a binary classifier. The fourth one is the artificial neural network, which mainly works like the human neuron system. The fifth one is the deep learning method, which is a recently developed method in this field of machine learning algorithms. Now, k-nearest neighbor method from the theoretical background and by using the MATLAB codes. Firstly, we have to understand that k-nearest neighbor algorithm works on the principle of Euclidean distance formula, which is a very easy formula. Here, this slide clearly indicates that when I learn the algorithm that from the known points, then it learn it. Uh, Here in this graph, you can clearly observe that first of all we train the KNN algorithm by using the category A data and then the category B data, and then we introduce a new set of previously trained data set. Then the KNN algorithm first apply distance formula and to which set of data it find the new red point close, then it classify it as that group of data and insert it in dead points. Now the further explanation will be given by the MATLAB simulation. Here you can see the MATLAB command window. The KNN algorithm function that is used in MATLAB is shown here, that is fitc_knn function. First of all, I train the data by using the set of some Keras level, and when my KNN algorithm is trained perfectly, then I validate it by using the samples of data from the newly data points, which are also shown here. And when I put that points, the KNN algorithm shows me that the gear has cracked. And when I plot the another set of data point, it also shows me that the gear is uncracked. The second algorithm is the naive Bayes classifier. The naive Bayes algorithm is a classification-based machine learning technique that works on the principle of Bayes' theorem, which states that determines the likelihood of an occasion happening given the likelihood of another occasion that has effectively happened. The naive Bayes classifier is a very efficient classifier and it has very high precision in determining the faults. That's why it is used in the transformer fault diagnosis, which is a very crucial machinery that we use in our electrical power systems and our electrical supply corporations, and is used by the electrical supply corporations. Now the third machine learning technique is the support vector machinery. I will first explain it from the theoretical background and then by using the MATLAB codes.
Support vector machinery is a regression based as well as classification based algorithm which is trained firstly by a set of labeled data so that when an unlabeled data is provided to it as an input, it develops a hyperplane. You can see the hyperplane on my screen, the graph. Hyperplane is a margin which separates two different classes of data in a high or low dimensional space, which can be utilized for classification and regression. Now, SVM can be classified into two categories, linear SVM and non-linear SVM. Linear SVM In linear SVM, the input unlabeled data can be separated by a linear hyperplane. But in non-linear SVM, it generally employs the kernel method for the classification of non-linear data. Kernel transforms the non-linear and also which is called the non-separable low dimensional feature space into a separable data of high dimensional feature space, for example from 1D to 2D or 2D to 3D. Now I will explain it by the MATLAB simulation and graphical permutation. SVM is also trained likewise the other machine learning algorithms. In MATLAB, we use the code fitsvm to train this algorithm. First, I train this algorithm by taking a sample set of data of different bearings. Among them, some of them are faulted and some of them are unfaulted. You can see in this graph on the screen that SVM after training has divided the unfaulted data into one group and the faulted data into another group and separated by the form of this circle. Now when I validate this by putting a set of arbitrary points, so it shows me that the bearing is unfaulted. You can see also in this animation that the inner race, outer race and the balls, all the elements of the bearings are unfaulted and the bearing is perfect to work in the working conditions.
Now the fourth method is artificial neural network. An artificial neural network is a useful asset with the capacity to perform classification as well as the regression task. ANN can be thought of as weighted coordinate diagrams, the neurons being the hubs and the association between the hubs being weighted connections. This learning modifies weight along with the activation function in order to obtain the desired results. ANN is basically human-aspired neurological systems. Neurological systems consist of three types of processings. The first is the input layer, the second is the hidden layer, and the third is the output layer. The input layer receives the stimulates from the environment as a feature vector. The output layer is responsible for the display of the final desired results via activation function, and the hidden layer performs non-linear alterations of the input data sources entered into the neural network. Here in this diagram you can also see that there is a bias factor. The bias units are also accommodated that add the additional features that were missing by the in the processing of the input and the hidden layers to obtain the desired results as an output. Types of artificial neural network ANN. Researchers have used the following types of artificial neural network. Number one is the MLP, which is called as multi-layer perceptron. Is a type of artificial neural network consisting of forward connection between the units in subsequent layers. The second one is the radial basis function RBF. It is also a feed-forward network having no weighted connections, consisting of only one hidden layer. But RBF is generally faster than MLP. The third one is the probabilistic neural network (PNN), consists of hidden layer of neurons that are not fully interconnected. The only difference between MLP and PNN is of exponential activation function. The fourth one is the recurrent neural network RNN. It is a network in which the output of some neurons act as a feedback to the same neuron or the neuron in the preceding layer. Therefore, it is also known as the dynamic unit. Now the explanation from the MATLAB simulation codes. The tool which is used in the MATLAB is the NF tool. The artificial neural networks also works on the same pattern as the other algorithm works. That first of all we have to train it by using some set of unlabeled data. Here you can see the plot of data which I have given to it for this training purpose. You can see that there is a linear graph, and the regression plot clearly indicates that since the value of r is near to the 1, so it is stable data. So we can say that the training is well good enough for the further function of this ANN tool. Here you can also see that the MATLAB has also given me the neural network, which is a very modern which is a modern advancement in this MATLAB tool function. Now for the validation, I have given it some new data points of the shafts for its validation function. Here you can see that it indicates that the shaft is deformed, and when I give it the new data points, it also performs well and gives a proper result, which is that the shaft is working properly. Now the most modern and most advanced AI technique is the deep learning. In most of the tasks, it is difficult to extract the features from the complex or non-linear input functions that can be fed to the traditional machine learning algorithms. The relation of different AI approaches is different from the deep learning. Such type of barriers in the fault diagnosis of rotating machinery can be overcome by using deep learning methods. The deep learning methods have multiple levels of automatic feature extraction, which tends to permit the system to learn the non-linear input, transforming input into the output directly. Deep architectures are required to map the complex functions, as these architectures consist of several layers of nonlinear operations. These deep architectures assist the deep learning methods to take the necessary information from the natural input signals and approximate an output with minimum error. Here is the list of some researchers that has used deep learning in their methods of fault diagnosis. Now, types of deep learning. Following deep learning methods have proved their credibility in the fault diagnosis. The first one is the autoencoder, the second one is the restricted Boltzmann machine, and the third one is the deep leaf network. Now, what is an autoencoder? Autoencoder is a basic three-layer neural network where input and output layers are directly connected to each other. It has many more visible units than the hidden ones. Autoencoders falls into the category of unsupervised learning, works on the principle of backpropagation. An autoencoder neural network involves two sections, encoder network and the other one is decoder network. The function of encoder part alters the information to a low dimensional space, and the decoder part remarks the input from the relating codes. Now, the restricted Boltzmann machine. Restricted Boltzmann machine are shallow, two-layer neural sets that comprise the basic blocks of deep belief network. The principal of an RBM is known as the principal layer of an RBM is known as the visible layer, and the second is the hidden layer, which is similar to the artificial neural network. Each circle addresses a neuron-like unit called a hub. The hubs are associated with one another across layers. However, no two hubs of a similar layer are connected. Deep Boltzmann machine (DBM) can be acquired by expanding the quantity of hidden layers. Now, third one is the deep belief network. In artificial intelligence, a deep belief network, which is abbreviated as DBN, is a generative graphical model, or on the other hand, a class of deep neural network made out of different layers of inactive factors, which are called hidden units, with association between the layers, however, not between units inside each layer. In deep leaf network, DBNs, the principles are: number one, the unsupervised learning recommendation to pre-train each layer means the each layer is trained early. The second one is the unsupervised train, one layer at a time, on top of the previously trained ones. The third one is the fine tune all the layers by supervised learning. Conclusion: faults in rotating machinery are the major problem causing phenomena for the industrialist nowadays because they are considered as obstacle for the progress of industry as they cause work interruption and economical losses. Therefore, these faults must be eliminated timely by manual means or by intelligent diagnostic systems. This report, this presentation has summarized various machine learning techniques to encounter these problems, including KNN classifier, naive Bayes classifier, SVM, artificial neural network, and deep learning. The application of these techniques are explained from both the industrial point of view as well as on theoretical basis. The computational MATLAB codes are also programmed with the training and validation results. The basic emphasis is that with the advancement of artificial intelligence, these methods should be used as an important and dominant tool for the fault diagnosis in industrial sector. Now, in the end, I want to quote a quotation of very famous scientist, namely Carl Sagan, who says that somewhere something interested is waiting to be known, which means that this is not the end of artificial intelligence. We have to do further more research and further more advancement in this field so that we can encounter our obstacle that we face in our daily life and make the life easy for the human beings and reduce the manpower. Thank you.